More dimensional analysis problems. Here's a question where we're trying to calculate the number of seconds in 8 years. Thinking about the answer, before we do any calculations, we know the answer has to be a big answer for it to be reasonable. So we're going to have the unknown, x seconds, set that equal to the known, 8 years. So in this case, we don't have any scientific prefixes like kilo, mega, pico. We're just changing one unit of time into another. The technique is still the same. We have to put years in the bottom for it to cancel. And now, what do you know about a year? Well, you could turn years into days. Again, put your units in before you fill in any numbers. How many days are there in a year? 1 year, 365 days. We're not done until the units convert all the way to seconds. So what can we turn days into? Well, we know there's 24 hours in a day, and then we could turn hours into minutes. Every hour contains 60 minutes, and then finally minutes can be turned into seconds. 1 minute, 60 seconds. And the nice thing about this technique is there are other conversion factors that would also work. So there's not just one method to get the correct answer. When we count sig figs, 8 years, the problem does not have the magic word exactly. If it said exactly 8 years, that would be an infinite number of sig figs. But because it just says 8 years, there's only one sig fig in that number. 365 days in a year, that's exact. 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute is exact. So our answer should only have one sig fig. The calculator answer, 2.528 times 10 to the 8th seconds, matches what we said it was going to be a big answer. But to write that with only one sig fig, look to the digit to the right of where we want to round this. That's 5 through 9, so we're going to round that 2 up to a 3. So the correct answer is 3 times 10 to the 8th seconds. This was an example of a problem where you had no conversions other than the ones that you probably already know. So the fact that there's 24 hours in a day, 60 seconds in a minute, that's something that most people will remember. Other conversions are not something that I expect you to remember. For example, here's a problem where you're given the conversion between tons and pounds and kilograms and pounds. If I don't tell you to memorize it, then you don't need to memorize it. A problem on an exam will be given with information similar to this. We're going to use exactly the same technique. The unknown, how many grams? The known, exactly 4 tons. And that word exact tells you you have an infinite number of sig figs. So tons can be turned into pounds using this conversion. And in this problem, I'm going to show you something that helps some students is don't worry about any of the numbers. Just first focus on the units to see if you can come up with grams in this case. So from tons, we can turn them into pounds. And then from pounds, we can turn them into kilograms using this given conversion. So now we have kilograms, but we want grams, but you memorized table 2.2, so you can turn kilograms into grams. So this helps sometimes to write everything out before you start putting any numbers in. And now we can use the fact that 1 ton is exactly 2,000 pounds. 1.000 kilograms is 2.205 pounds. And then kilo from table 2.2 stands for 10 to the third. that has to go in the opposite side of the fraction, in this case the top, because kilo is in the bottom. And our calculator answer, 3.62812 times 10 to the 6 grams. Grams is a very small unit of mass. Ton is a very large unit, so it makes sense if we're measuring in a small unit, we should get a big answer. As far as the sig figs go, 1 ton, exactly 2,000 pounds, so this conversion has an infinite number of sig figs. The kilograms to pounds is a normal equal sign, so this is 4 sig figs, top and bottom. And then we have a conversion from table 2.2, that's exact. So the smallest number of sig figs is 4. Starting from the left, 1, 2, 3, 4 sig figs. Look at the number to the right of the 8, it's a 1, so we're going to round the 8 down, keep it an 8, 3.628 times 10 to the 6 grams.